Good morning, scientists. We have a new science teak for us to study today. So we just finished our unit on types of energy. Remember, so we used MELTS to remember our types of energy. So we had mechanical, electrical, light, thermal, and sound. So this week we are going to be specifically focused on electrical energy. So we're going to really dive into electrical energy, and we have a teak specific to electrical energy. It's one of my favorite teaks actually that we study. So the teak is this 4.6c. It says demonstrate that electricity travels in a closed path creating an electrical circuit. So to demonstrate, that means we are going to show, what are you going to be showing? That electricity travels. So if you're traveling, you are moving, right? So when you travel on a trip, you're moving places, right? You go from one place to the other. So electricity actually travels. It's not something that stays still. It's a moving part. So it travels in a closed path. This is going to be kind of the most important thing here. It travels in a closed path, which is called a circuit. So this closed path, it's the same thing as a circuit. Now, a closed path is going to refer to like a circle. So if I have something and it's going to be going around and around and around and around, this is a nice closed path, right? Electricity flows in a path like this. It's around and around and around. Now that's closed. Now if I go like this, look, now it's open and it can't continue anymore. So it could go like this, and then it stops, right? Because it's open, it can't finish. And it's not able to close the path. So this is called an open circuit, where if it's not fully connected. Now if I close it, look, it can keep going around and around and around and around forever and ever and ever. But again, if there's a break in it somewhere, it's open and stop. I'm stuck, right? And stuck. That's an open circuit. It can't move. So electricity has to flow in a closed path, which is an electrical circuit. So that's what we're going to study today and what we're going to look at. Let me show you an example of an open path and a closed path circuit using some of these tools here that typically we would use in the science lab, but since the science lab is closed, I'm just going to show you here an example. So here I have a battery. Fits inside this little battery case. So I'm going to put my battery in. And here I have a light bulb. It's just screwed into this light bulb holder. So here's the light bulb, and it screws in to this light bulb holder. And then I also have some wires here that I'm going to use to connect my battery to my light bulb to try to create a closed circuit. Well, right now, I don't even have a circuit at all. These are not connected. Remember, I want to be able to go around and around and around in order for this to work. So I'm going to use my wires. I'm going to connect from my battery to the light bulb. So here we go. I'm going to go here from my battery. I'm going to connect this end over to the light bulb. Okay. Notice nothing happened yet, right? The light bulb is not shining. It won't be very bright, but it's not shining yet. And why is it not shining yet? Because it's not going in a complete path yet. I have energy coming out of this battery, going down this wire, going into the light bulb, but that's where it stops, right? To make it actually flow, it's going to have to keep going and go all the way around and create a full circuit. So let's keep going with my circuit, see if I can get this flowing even more. So I'm going to connect here from the light bulb. Well, now, shouldn't it be working now? Because I'm going from the battery to the light bulb and keep going, but here, look, it has stopped. So what I need to do right now, this is an open circuit. What I need to do is close this circuit up by touching this wire to my battery post right here. And now once that happens, I should be able to have a continuous flow, and it should be able to keep going through and it will make my light bulb light up. So once I close this circuit, it should be able to flow smoothly without being stopped, because right now energy is leaving the battery and it's flowing all the way through here. It's flowing all the way through the light bulb, flowing all the way through the yellow, and now it's stopping right here, which is why it's not working yet. But once we connect this to this, it should then be a continuous path and it should work. So let's cross our fingers. Let's see if it works. Did you see that? Look, now it's on. So now that I have a complete path, it's leaving the battery, flowing through the wires, through the light bulb, back through this wire, and then back through this battery. And it's a continuous closed path. We have created an electrical circuit. Now, if I open this circuit anywhere along the path, it will stop. So if I open it here, look, it's off, because now I have an open circuit. I've broken my circle. Look, it's not a circle anymore. I've broken it. But if I close it, it works again. So it doesn't matter where I break it. Look, I'm going to break it here. It's not working. To make the circuit actually work, we need a closed path and a complete closed circuit for this to work.